Today I'll be doing the module number 3, graph abstraction cost. And in this video, we'll observe the graphs, how the graphs are abstracted and how the costs are calculated. So the question is, what is the least cost between the path U and Z? If you want to transfer a packet from the source node U to destination node Z, how the cost of the path has been calculated. You can observe here from U to V, the cost is 2. From V to W, the cost is 3. And W to Z, the cost is 5. And here we have to find the least cost to transfer the packets from the source node U to destination node Z. The routing algorithm is to find the least cost path, because when we transfer a packet from source node to destination nodes, we have always needs to find out the least cost which is used to transfer from source nodes to destination node. So here we are seeing the different routing algorithm classification. One is the global or decentralized information. The all routers have complete topology link cost information. It is a link state algorithm. And in a decentralized mode, the routers know physically the connected neighbors link cost to the neighbors. The iterative process of the computation exchange info of the neighbors. And whether the static or dynamic routing algorithm as used. In the static, the router changes slowly over the time. In the dynamic, the routers changes more quickly. It is a periodic update and in the response to the link status changes. Here we see in this chapter the link state algorithm. A link state algorithm we usually call it the distrust algorithm, where the net topology link cost known to the all the nodes. In the nodes, the cost of the each topology will known in advanced. Accomplished via link state broadcast, the all nodes have same information. The computes the least cost path from one node source to all other nodes. First, initially, we need to find out the least cost path from one source nodes to all the nodes, which gives the forwarding table for that node. The iterative, after the k iteration, we know the least cost path to destination nodes cost k. And we use the notation C of x comma y. The link cost from the nodes x to y, which is equal to infinity, which is say that there is no direct neighbors. If there is no direct neighbors from the source node to destination node, or from one node to another node, we denote it as a infinity. D of v, the current value of the cost from path from source node to destination node. P of v is a preceders node along with the path from source nodes to v. N is a set of nodes whose least cost path definitely known. The distrust algorithm, you can see here, which is the algorithm in the first step with the initialization. N is equal to u, we initially draw the vectors for all the nodes v. If the v is adjacent to u, then d of v is equal to c of u comma v, else d of v equals equality. So find w not in n such that t of w is a minimum. Add w to n star, update d of v or all the v adjacent to w and not in n. So we find out d of v equals minimum of d of v, d of w plus c of w comma v. So you can see in the example how the cost has been calculated from each node. So here we construct the shortest path tree by tracing the preceding nodes. The tie can be broken arbitrarily. So finally, we get the resulting shortest path tree from U to source destination Z. So algorithm complexity, we can compute that for the n nodes, each iteration need to check for all the nodes, which is not in n into n plus 1 divided by 2 comparison, which is O of n square. More efficient implementation possible, O of n log n. So we have not taken the traffic as a weightage. So oscillation is possible to support the link cost, which is equal amount carried out to traffic. Next, we'll be seeing about the Bellman-Ford equation, which is called the distance vector algorithm, which comes under dynamic programming. So Bellman-Ford, so clearly d of e of z equals 5, dx of z equals 3, d of w comma z destination is 3. The Bellman-Ford equation say d of u of z is equal to minimum of c of u of p plus d of dv of z, c of u of x plus dx of z, c u of p w plus dw of z. The minimum we can compute like 2 plus 5 comma 1 plus 3, 5 plus 3 equals 4. The node achievement minimum is next. The hop is the shortest path used forwarding table. So which completes the session 4 of the classes.